Hello everyone, I'm Xiao Gang. Okay, in this chapter, we'll look at assertions. This chapter is actually quite relaxed. We won't go deep into assertions. Why is that? Because with assertions, you just need to know roughly a few categories, and knowing one or two or three is enough. There's no need to delve deep. At this stage, there's no need to delve deep. Just understand what differences they have, and which scenarios to use, which assertion. This is because it's engine level stuff, and they generally really like using these assertions. Because their engine code is already very complex, many times when problems occur, it's not easy to troubleshoot. So assertions must be used to assist development. Anyway, we should use assertions cautiously. In this chapter, we'll mainly read through the documentation and then write some tests. Just simple test code. Later, we have a dump file from before, and we'll read that dump file for everyone and add it to this chapter as well. First, let's look at the documentation. The translation of answer is assertion. An assertion is used during development to help us detect and diagnose abnormal or invalid runtime keys. Then we often judge whether this pointer is null, whether the divisor is 0, or whether the function is running recursively, and some important assumptions. However, this method will result in low efficiency. So in such cases, then this kind of thing can only exist during development. And when we officially release, these statements must be removed. It is mainly used to detect bugs, and its characteristic is it does not exist in the released code, so it is particularly good. Simply put, an assertion is this piece of code that must execute correctly, otherwise an error will occur. That is, I wrote this function, and I require you to pass this type. But the pointer you pass might be valid. If this pointer is invalid, for example, you pass a null pointer, or a pointer that is not of this type, okay, then I assert, I just won't let it go to the back. Because I avoided a series of subsequent problems. Because all of my logic is based on the validity of this child specialization. My type is correct. Only then will I read the parameters inside, and then execute the subsequent functions. If you are wrong from the very beginning, then we will simply let it crash, thereby avoiding introducing a more complex scenario. So this is a very good use of assertion. Then we often see this in films. When we get our instance, when we obtain our world, it will, or when we do type checking, there is a cast check, right? So actually, the check sometimes has this assertion. So this assertion is mainly divided into three main sequences. That is check, verify, and ensure. And then it is in the engine's runtime. Core public Misc. Answer making above. Then we can open and take a look at this file. It is actually in a C engine source. It is a module under Runtime. Then find our core. Then find our public. Then let's take a look. The path after it is miscellaneous message. Then find this shell macros. You can see there are a lot of comments here. Your assertion is actually at this location. If you're interested, you can look into it further. Okay, let's continue reading our document. Then check is the most basic and fundamental one. It is also the most forceful check. As long as it's a false, it will stop execution. And by default, it will not run in the release version. Then this checks macro. You can basically use it like this. Inside, you can pass some parameters. This is an expression, right? And here you can also input some formatted text. Actually, sometimes when we load a data table, it may ask you to pass a string. This string is used when it reads the table. In case of a read error, it will log this string, telling you that the error occurred here. The error occurred while executing this format text. And here you can put some code or execute it more than once. That is, the first break is fine. If it executes multiple times, then there is a problem. And this type is for checking recursion. Check. That is to say, this is to prevent multiple entries. This is to prevent recursion. This is the same. Actually, it's this force. It is mainly used for virtual functions that will not be called because they are overridden. Actually, if you want to look at it, just look at it like this. Because there are too many. Looking at cancel search. If we just give an example, you can see. Look. There are many checks here. Actually, we can make it match case here. Then we should add a parenthesis to it. This is a little search tip. That is, when you write a function name, you should also write it this way for internal names. This way, when you troubleshoot, you can see check force. Then I wrote an expression you see inside the engine. It actually uses a lot of this stuff, but that's the engine. The engine can be written this way. The most commonly used one is this. That is, this thing must be game instance, or it must be on the render thread. Because, we render this engine in real time. Render thread and our game thread, their interaction events have this requirement. That is, they will have a requirement. So this place particularly emphasizes must be on the game thread, or return a different one depending on the situation. Like this, if it is on the game thread, it will generate direct uClass related information. If it's on the render thread, it will specifically return some F-class types. There is specifically some data. It is copied from the game thread. It is a relatively safe thing. Okay, so this check is quite simple. Actually, we can just show it to him. Look at this place. If you use default, it will be wrong. It proves you did not assign this data. Then it is completely incorrect. So this is called checkNoEntry. Okay, no problem. We can do it this way. I will give an example like this, which will be clear. I think it seems there is an incorrect space here. You can see check low. This is the place where it is used less frequently. Then you can see some comments here. This place is meaning it can only be executed once. Yes, if you break it multiple times, it will report an error. This checks whether the low-level situation occurs. Look here. There should be a check here. Okay. Then this place, you can see some red. Actually, it is like this. That is, when we are debugging in environment test or shipping editor, it is generally present, but sometimes in order to control it with something you need to control whether this red text exists. Then to control this red text, how should this value be controlled, right? Then you need to look at this build point. Is it necessary to configure our UBT or UBT, a parameter of UBT, when you give it a Boolean value there? Then he said something like, then you can then set it to true. Then when he defines it here, he will define it as this one. Just do it like this. That's fine. Okay. As for verify, actually, they are independent. Then verify is actually similar, and you must be careful. That is, never write your game logic into this verify. That is, write it into this parameter. For example, if you check then a plus 1 equals operations like a plus equals 5, then it will cause a problem. That is to say, if in your release version this thing has been removed, the code inside is never executed, then this line of code will be missing in the release version. So do not use these methods to write something like, that is, do not put your business logic. You can query, but do not write your set method into this parameter. And this is a kind of verify information. Actually, verify is used relatively less. We generally use check and ensure more often. You can look for it. You see there is a verify here. You will find that this area is all of this kind of operation similar to a query. Yes, you can see it, right? It will modify the value here, because in the official version, this code might be removed. It might not execute. If you modify the text here, there will be errors. This is a verify. You can also format the text, output something. Then, if you slow it down, it actually only exists in the debug version, one line. The front part is the same. Then this ensure. We actually use it quite a lot. The advantage of ensure is that when we say, although your code executes many times within this application cycle, it only reports the first time. Yes, and you can also continue to proceed, so ensure is quite convenient to use. But if you want it to report every time, you use ensure always. So our recommendation is generally to use ensure and check for something a bit heavier. We directly use check, and for something lighter, that won't cause major issue. We can see search for ensure here, cancel it. You can see it ensures that it is found, and if you don't find it, It's actually fine. Ensure this is unique. And some other parameters you see, okay, good. So we are the same. You can see that is, if you ship it, this ensure is removed. Actually, after we build the shipping package, after building it, our logs that comes with all these assertions are removed. The logic here is actually a bit like if sometimes we write our effects. Some of our things, we write some of our business logic into the effects, or write it on the animation montage, right? Or write it on the audio. This will cause these effects not to be executed correctly, or to be called. The reason is that the engine optimizes it for you. It thinks that when I build a shipping package, or when I'm on a dedicated server, these things should not exist. Then after it optimizes done for you, you will find that the position calculated by your Google is different on the dedicated server, and then your assertion. These codes are not executed after the shipping build. Anyway, this is a common mistake that is often made. Okay, above us some simple test cases like this. For example, this place needs to be checked. Our object must exist, because you may need to perform some calculations on it later. Then this is a wordy method. That is, you need to obtain this thing. It should not be empty. Yes,